In this video, we're going to cover a system of linear equations through graphing. This is one of the three common methods of solving systems. Before we begin, let's look at the different possible solutions. The first one is one solution, and that means the two lines are going to be intersecting at one point, and that point will be your solution. The other option is no solution, when two lines are parallel to each other and they do not intersect, like the blue and red line. And you also have infinitely many solutions, and that is when one line overlaps the other. So in this case, as you can tell, the color of the line is purple because the blue line is on top of the red line. They're overlapping. For example 1, we will go through each step carefully. As we move on to the next examples, we won't be reading all of them. But for example 1, the first step tells you to write the equation in slope-intercept form. And you have the example of what slope-intercept form is in the form y equals mx plus b. M is your slope and b is your y-intercept. The m is going to be the coefficient or the number that is being multiplied with the variable. In the blue equation, the slope is going to be 3. So I'm going to write m is equal to 3. And the y-intercept, the b, is going to be negative 4. That is going to be our starting point. For step 3, we're going to graph the y-intercept at 0, b. b is negative 4 for the blue equation. So we're going to go to our origin and we're going to drop 4 units. 1, 2, 3, 4. And that is where our first point is going to be. And then for step 4, we're going to use rise over run to find the second point. If the slope is positive, move up, then right. In this case, our slope is 3, and it's positive. So we're going to go to our intercept. We're going to move 3 units up, 1, 2, 3, and we're going to move 1 unit to the right. Anytime that you have a whole number, you only move 1 unit to the right. Now that we have those 2 points, we draw a line to connect them. Now that we have the blue line, we need to work with the green line. So we're going to repeat steps 1 through 5 for the second equation. In this case, it's already in the form y equals mx plus b. The slope, again, is 3. So we write m is equal to 3. And the y-intercept is going to be 1. So b is equal to 1. So we go to the origin, we go 1 unit up, and that's where we're going to put our first point. And now, because the slope is positive 3, as stated in step number 4, we're going to go up 3 units, 1, 2, 3, and 1 to the right. Now, let's connect the points. Now that we have both lines, you can tell that those 2 lines don't intersect, and it says, write the solution of the system of linear equations. Option A, one solution, the lines are going to intersect at one point. B, no solution because the lines don't intersect. And C, infinitely many solutions because they're overlapping. So for this example, we have no solution. So let's write no solution. Once again, we're going to follow the same steps, but because we went over them in detail in the previous example, I'm going to be able to skip a few things. So we're going to start by writing things in slope and intercept form, and the blue equation it's already in that format. So now we find the y-intercept and the slope. The slope is going to be -2. Your y-intercept is -4. So our first point is going to be a -4, and because the slope is negative, we're going to go down and to the right. So our first point is going to be a -4. So right here, and now we go down 2 units and 1 to the right. Now that we have those 2 points, let's connect them. This problem now is slightly different because the green equation is not in the format y equals mx plus b. So in this case, we're going to have to add 2 to both sides. With that, we're going to add 2 to both sides. And we have y is equal to x plus 2. Now, your slope in this case is going to be 1. That is the number in front of the x, just an invisible 1. And the y-intercept is going to be 2. So b is equal to 2. So our first point is going to be at 0, 2. So we put our point right here. And because the slope is 1, we're going to move 1 up and 1 to the right. And now that we have those two, let's connect the points and make a line. Now to find the solution, we need to figure out if the lines intersect at one point, they don't, or they overlap. And in this case, they do intercept at one precise point. And that point is going to be at x -2 and y 0. So our intercept is going to be at -2 and 0. And that is the answer for this system. For example 3, similar to example 2, in the blue equation, the y is not by itself. So we're going to have to add 2x to both sides. And remember that you cannot add constants and variables. So we end up with 2x plus 3. The slope of this one is going to be 2, and the y-intercept is 3. So we're going to start at 3. That is going to be our first point. And now we're going to go 2 units up from that point and 1 unit to the right. And now we connect those 2 points. And now you see that the green equation has the same slope. M is equal to 2 and B is equal to 3. So our first point will be at the same spot at 3, and now we will have to move 2 units up and 1 to the right, and that means that we will actually end up putting the next line on top of the blue line already, because this is where our next point is. So in this case, we know that because one line is overlapping the other one, this is going to be infinitely many solutions. And that covers the 3 different solutions for solving system of linear equations through graphing. Some of the equations will have slopes that are fractions. That doesn't make any difference. You still graph the same way, but instead of moving 1 to the right, you will just move based on the number that it's the denominator.